Alright, so the more I've been taking a look at this event-driven architecture, the more I realize I'm probably going to need a solution that's a bit more flexible or dynamic, something more robust than what I've been getting with that queue-centric workflow pattern that I love so much. Like, at some point, I'm going to need a solution that'll let me set up complex routing rules, all without having to crack open and redeploy my services, at least where it's easy enough to change up or add new targets in a production environment. And that's what got me messing around with AWS's EventBridge. They used to call it CloudWatch events, so it was kind of hiding under the radar. But that said, it seems pretty cool. You can set up any number of event buses with routing rules that'll let you forward different kinds of messages and events to any number of targets in a distributed system. Now, of course, I wanted to get my hands dirty and start building proofs of concept, but I needed a use case with a bit more tooth than a basic hello world, and then it hit me. The other day, it was all over the news. Claude Code's source code got leaked, and the funny part was seeing how they'd used basic regular expressions to monitor end-user sentiment. Like, they were just pattern matching for frustration and swearing. So I figured what's good enough for the big guys is good enough for me, and I went ahead and built a little mood moderation service, a Lambda function that gets invoked by a simple text ingestion service, and I just log the results in CloudWatch. Easy enough. So here's what I ended up with. The Message Submission service is a basic Lambda function. I configured it with a function URL so I can pass in the text using the browser's address bar with a query string, and I can keep it public. And this first function cleans up the text so I can pass it along to the EventBridge event bus. This way, it doesn't have to actually know anything about the receiving service. It just sets it and forgets it. And since Lambdas are already hooked up to CloudWatch, it's pretty easy to leverage the service and log the request, and I'll show you that in a bit. I added this IAM role so we can give the message submission service permission to actually submit events and write to the log. From there, we configure a rule on the event bus so it knows where to send it, the Message Moderation service. And this function gets its own IAM role as well. That way, it's allowed to post logs. We'll use that to see the moderation results. But yeah, each Lambda gets its own role, principle of least privilege. We're also going to need to attach a resource policy to our message moderation service. This allows that EventBridge rule to trigger an invocation of our function with an event. And that's kind of it. Let's check out the code. Alright, here I got a solution open in VS Code. It's got both my Lambda projects. That'll be the Event Producer service and the Event Consumer service. If I click on the first one, the Message Submission Lambda project, we can see the C# proj file. I picked .NET 10 for the framework, and the AWS project type is set to Lambda. That'll help with the packaging that happens later. You can also see I've added these Lambda and AWS SDK dependencies to help with serialization and EventBridge calls. We'll take a look at that in a bit. Cool, now we can pop open the message submission function file. That's the main entry point for the Lambda. Up at the top, we got some library references to help with the web stuff and the Lambda stuff. Here on line 6, we got this assembly attribute to tell the Lambda how to deserialize the web request. Now, inside that class, we got this private publisher field. That's a reference to our wrapper class that handles the EventBridge integration. Now, this function handler method is the one we configure as the handler when we set up the function in AWS. The request and response get deserialized and serialized using these classes we got down here at the bottom of the file. Raw query string comes in, status code and body go out. Back up here, this chunk of code does the work of parsing the text out of the query string. And next, before we lob it off to the event bus, we log it using the logger, baked into the Lambda context. No need to build up a separate client for CloudWatch. We get that part for free. Notice the demo prefix that'll help us filter the logs later on. From there, lines 25 to 27, that's the main bit of business logic. If the user passed in text, we get to call the publisher. We can go ahead and right-click, go to definition, and check that out. And there's the asynchronous publish method in the EventBridge message publisher file. We'll start by serializing the text into the detail field that the EventBridge is expecting, and with that we can build up the request object. A lot of those fields are grabbed from environment variables that get set in the Lambda configuration, bus name, source, and detail type. And while we're initializing private fields, here's the EventBridge client. Now with all that set up, we can call the PutEvents method with our request object, and there we go. Grab the response and head back to the function class. Set the status code and body, and then we can log it. Great, with one Lambda function down, we can click on Message Moderation Lambda and check out the project file. Just like before, .NET 10, Lambda project type, and some more Lambda library references. This time we've added CloudWatch events to help us read the EventBridge events in the C#. Open up the project, click on the Lambda function class, got the Lambda and CloudWatch event references, and there's that assembly attribute. Tells it how to deserialize the request. Down into the Message Moderation function class. Initialize the private field for the service class, and then we can check out the handler. Again, we got this moderation event class to help shape the deserialization. Grab the event, log it, and go ahead and call the evaluation method in our service class. Go to definition. And here's the Message Moderation service class. Split the words up into a list and then match it up against the flag terms we got up here at the top. You know, the kind of language you wouldn't want to use in Sunday school. Cool, we can shape up the result, flagged or clean, and head back to the function class. And here's the log we're going to be interested in. We can use this to gauge our user sentiment, just like Anthropic. Now that we got the code, let's package it. Head to the script folder and open up one of the bash files. Here you can see we're calling the .NET Lambda package utility to build the project and zip it up into a Lambda-friendly deployment package. And here in the packages folder, you can see the zip files we created. Good to go. Alright, let's head over to AWS. For the demo, I'm going to go ahead and manually provision everything I showed you earlier, but once you figure out all the bells and whistles, you're going to want to automate it. Okay, first off, I went ahead and opened the EventBridge console, and we'll head over to the Event Buses page. Architecturally, this is the center of the universe, so we'll start there. Click Create Event Bus, give it a name, Message Moderation Bus, keep everything else default, and Create. Now we can copy the ARN for later. Next we can build up the roles, one for each Lambda function. Create role, keep AWS service selected, pick Lambda for the service and the use case, next. We'll add a permission policy. Search for AWS Lambda basic execution role. That gives it permission to write logs to CloudWatch. Next. Give it a name, Message Submission Lambda role. Scroll down, create role. Here we can see it in the roles list, but we still got one more thing to add. We're going to give it an inline policy. Select a service, EventBridge. Action allowed, put events. That's going to allow the Message Submission Lambda to send messages off to the event bus we just created, and then paste the ARN here. Click Add ARN, and Next. We got to give our policy a name. Allow EventBridge PutEvents policy. Click the Create button, and there we go. Back to the roles list, and we're going to create another role. Find the basic execution role. Next. Give it a name, Message Moderation Lambda role. This one only needs permission to write logs, least privilege. Create the role. And that's it. Now we can go ahead and create the first Lambda function. Author from scratch. We'll name it Message Submission Lambda and select .NET 10 for the runtime. Scroll down, expand the additional settings. We'll keep the default x86 architecture. Select Custom Execution Role. We can select the message submission role we just created. Click Save. And for networking, to enable the browsers to make calls to the Lambda, select Function URL. Change the auth type to none so we can hit the endpoint without having to log in. Allow Invoke Function URL. We're going to delete the function after the demo, so this will be fine. Hit Save. Then we can scroll down and click Create Function. And there it is. Copy the URL so we can navigate to it later. And now we're ready to upload the code. Upload from zip file. Go ahead and add the Message Submission Lambda zip file we created earlier. Save it. Next, we got to change the default handler. Hit Edit and enter our function's assembly, class, and method name. Hit Save. Cool, and from there we got to add a little configuration. These are the environment variables that our message publisher class was looking for. Click Edit. Add environment variable, event bus name, that's the name of the bus we just created, event source, a JSON-friendly name for the Lambda, event detail type, message submitted. That's the information that gets used for routing and logging later on. Click Save. And there we go. Normally you'd test the function out by itself first, but we can just go ahead and build out the rest of the solution. Okay, create function, author from scratch, name it Message Moderation Lambda. Pick the .NET 10 runtime, additional settings, select custom execution role, and pick that other role we created for the moderation lambda. Save it, scroll to the bottom, and create function. Just like before, we're going to add our code. Upload from zip, Message Moderation Lambda zip, hit save, and there we go. And again, we're going to edit the function handler. Assembly, class, method, and save. Now before we attach the resource policy for the event bus rule, we need to actually create the rule. So head back to the EventBridge console, and this time we'll head over to the rules page. Click Create Rule, and to keep things simple, we're going to use the default rule builder form. Enter the name, route to Moderation Lambda, and go ahead and pick the event bus that this rule applies to. That's the one we created earlier, Message Moderation Bus. Hit Next. Scroll down to Event Pattern. We're just going to paste in a basic custom event pattern with JSON. Here we're saying if the source of the event is Message Submission Service and detail type is Message Submitted, go ahead and do the routing. These values come from the environment variables we created earlier. Scroll down and hit Next. And now we can pick the target or subscriber for the event. This is the second function we created, Message Moderation Lambda. Scroll down and click Next. Review and create role. Great, now from here we're going to want to head back over to that Message Moderation Lambda that we created earlier. This is where we attach a resource policy to give the rule permission to invoke our function. Hit the Configuration tab, click Permissions, scroll down to the resource-based policy statements, click Add Permission. And this is for an AWS service. Select EventBridge, give it an ID. And don't forget to grab the ARN for that rule we just created. Message Moderation Bus, route to Moderation Lambda, and copy the ARN. And then we can paste it into the policy source ARN field here. Action is Lambda invoked function, and save it. And there we can see EventBridge now shows up as a trigger in the function overview. If we scroll down to peek at the policy we just created, there's a source ARN conditional. Great. And with that, we should be all set up. We can go ahead and invoke our Message Submission Lambda and see if everything works. Pop open the browser, and here you can see the default path doesn't have a text value, so we get the 400 code. That's good, that's what we want. From there we can type in a basic hello world string, status code 200. The message has been handed off for moderation. Simple enough. This is what you'd look for if you had a client app waiting for the HTTP response. Next, I'm going to use this helpful URL encoder form. It'll let me type out a bunch of test text. Gosh dang it, golly gee, and that's a frustrated user. Encode it. Notice all the %20s for spaces. Copy it, head back to our submission page, paste the encoded text into the query string, and that's it. We'll enter a few more. Oh crap, what the heck? Dang idiot. Terrible language. Encode it, copy it, head back. Paste it. And we can do one more, this time some happy text. Encode it, copy it, tab, paste. Now you'll notice that we're not getting any feedback about the results of the text moderation, and that's expected because the service call is asynchronous, and that allows the client to respond quickly to the user so they can get to their next task without having to wait around. That's the trade-off of event-driven architecture. That said, how would we go about seeing the results? Well, this is where the CloudWatch Logs come in handy. Head back to the Lambda page, and they got this shortcut to the Logs page on the Monitor tab. Click View CloudWatch Logs, and that takes us over to the Submission Lambda's Log Management page. Scroll down and you can see the latest log stream. Click on it, and there's all the log entries. Now at first glance it looks like a lot of noise. This log stream is capturing more than just our own custom messages, but also the startup messages from the Lambda service itself. Click on the Clear button if you got any default date filters, and since we prefixed all our logs with demo, we can type that in and get a filtered list. Expand the window and check it out. Here you can see our initial call when we first opened the URL. No text string, but also notice how there's a second empty call as well. That's a side effect of testing with a browser. It actually made a second call to try and load that icon image for the tab. You'll see one of these for each of our requests. If I'd used a test harness or a tool like Postman, we wouldn't see those, but that's fine. And there's the hello world. Gosh dang it. Oh crap, what the heck, and this one should be fine. Great, now let's see how the moderation service handled the invocations from the event bus. Back to the Lambda list, click Message Moderation Lambda, Monitor tab, and view the CloudWatch Logs. We can scroll down and find the latest log stream. Click on it. Just like before, there's all the logs. Clear out the dates, filter for demo, and expand it, and there's the results. Each request has 2 entries, one for invocation and one for processing. Hello world is clean, no matched terms, but that next one got flagged. Dang, gee, golly, gosh, alphabetized. That next one too. That's some terrible language, and that last one, as expected, is clean. Nice. Now, obviously the use case for this demo was real simple, but hopefully it'll give you a sense of the different kinds of solutions you can build using event buses and rules, and how it can be pretty flexible for all the different kinds of communication requirements between your services and those more complicated distributed architectures. Anyway, this was a fun experiment for me, and I definitely learned a thing or two. I appreciate you checking it out. My name's Steve, and you can follow me on YouTube or LinkedIn. Take care.